Hi guys, in this tutorial we will be discussing about algorithms and analysis of algorithms, and if time permits we will be going through various tools to analyze the algorithms also. So let me start with algorithms. So what an algorithm is? An algorithm is some sequence of steps. If those are followed in some particular order, converts the input to the desired output. Okay, so this is basically how you solve a problem. You have an idea to solve a problem, so based on that idea you have some set of steps, ordered steps, one operation after other, this way. Okay, so those steps, when put in a format so that other persons can understand, so that format is called the algorithm. Algorithm is, why do we write the algorithm? First of all, because we want to formalize the idea. We want this idea to be formalized because we want others to understand, so that we can have some kind of mathematical proof to prove the correctness of the algorithm. Okay, so these are very advanced topics, so we are not going to that. For now, an algorithm is some set of steps which converts your inputs to the desired output. Okay, so let me write it here. A sequence of steps to find desired output. Okay, very basic thing. Let me take an example also. Suppose you are given a problem to take two inputs from user and then print the sum of the two on screen. Okay, I'm not actually talking in terms of hardware. I'm just writing something which can be applied or can be run on any machine, so that's hardware independent. Okay, so let me first write. Say I have an algorithm A which takes two input, A equals to 10 and say B got value 20, and the sum of these two is 30, and say I am calling this algorithm A. So this algorithm A is some set of steps which are applied on these two inputs, and this produces the output 30 and it prints it on the screen. Very basic idea, right? So how would A be looking like? So I am actually writing algorithm, the definition of algorithm A, or the body of algorithm A, in terms of how it define the functions in C. Okay, so like C, you have main, so you have start here. This can be anything. Okay, I am just writing so that it's compact and easy to understand. So there is a starting point for this algorithm. You take these values from user to, so take A and B. Then what you want to do, you want to store the results of summation into C, and then you want to print C on screen, and then you stop. So this is your step 1, 2, 3, 4 and 5. So these are these 5 steps. You can see there is nothing unnecessary. Everything is there in their own place, because before adding we need to understand the values. So we took the values from user, so you can see that everything is in its own place. So this is the feature of an algorithm. It wants everything in place, no unnecessary step. It should produce the desired output. This is producing the desired output. C is just the addition of these two numbers. This is not multiplication or subtraction of these two numbers. This is addition only. Okay, so this is producing the desired output only, and very short, easy to understand. So this is how you should write your algorithm. Okay, now we know how an algorithm looks like. You can use your own language to write your own algorithms. That's for the sake of humans only, right? Machines need some language like C, C++, and these are for humans. Okay, so the other thing which you need to understand is analysis of algorithms. So why do we what is the meaning of, first of all, analysis of algorithms? Suppose you wrote a program and you just okay, not in terms of program. You write an algorithm, and now you need to understand what are the results, is the result correct, what is the time requirement for this algorithm, what is the space requirement for this algorithm. So these are the parameters which you need to understand, and based on your analysis you need to update or modify your algorithm. So it's very basic approach, right? Say you have a problem P, and there are two such algorithms, A1 and A2. As a software engineer, if you were told to solve this problem P, you wrote, so this is your algorithm and this is the algorithm from your competitor employee. Okay, so these two actually is going to decide who is going to take the promotion. So some kind of analysis should be there, right, so that your manager can understand which one is better. So the same thing applies here, that we need to get the algorithm which is better among all. Okay, so now we understand why we need to analyze the algorithm. Now how to analyze the algorithm? So for that there is a term called asymptotic analysis. So now what is this asymptotic analysis? So the asymptotic analysis is a concept taken from asymptotes. So you understand what analysis is. Okay, I'm not going to explain this now again. So we are now studying or understanding what asymptotic mean. So in mathematics you have wrote or you have used this function, and you might have drawn the graph also for this function, and this is x and this is y. Okay, so for x equals to 1, this y is taking value 1. For x equals to infinity, y is taking 0. For x equals to infinity, x equals to 0, y is taking infinity. So there is this kind of curve you might have seen, and you can see the gap, which is decreasing each time. Okay, but it's never going to vanish. This gap will always be there, or you can say that these two touches each other. These two, this line and this curve touch each other at the point of infinity, or you can say that they are never touching each other. So at a very higher, very large value, you will be saying that at a very large value these two touch each other. Okay, so from here we are actually concerned with this part or this part, that how your curve, like this curve is not touching. Okay, this curve is not going beyond below x, and this curve is not going this side of y. So what are we telling, that how your curve or your function is behaving when the input size is too large, or in other words how your algorithm is behaving, because your algorithm is anyhow some kind of function is there, some kind of polynomial is there for your algorithm. Okay, okay, so let me first explain this thing. Forget about everything, just understand this thing. Okay, rate of growth. So say fn is n square and gn is n plus 2. Now you need to understand which is a function which is growing at a higher rate. So this is n, this is fn, and this is gn. So for n equals to 1, fn is 1, but this is 3. For n equals to 2, this is 4, and this is also 4, right? And for n equals to 3, this is 9, but gn is 5. So at this point, for n equals to 3, f is having a bigger value than g. So what does it mean? That f is actually growing at a faster rate than g. Okay, or you might have if you understand what differentiation is, so it's quite simple mathematics, right? So in terms of graph, if f is initially 1, then 4, then 9, so this is the graph for f, and this is initially 3, then 4, then 5. So this is the graph of G. So you can see that if you draw a line at any point for this curve G, the the rate of growth, or the differential curve, you understand what differentiability, right? So this is the tangent on this on this curve G, and this is the tangent of this line, this curve F. So that's the angle here is quite bigger than this angle. This is a smaller angle, this is quite thrice of this angle. So we are actually talking about the growth rate of the functions. So here growth rate, or the angle with x-axis of function f, is higher than growth rate of, or the angle of G with x-axis. So now you understand what the growth rate is. Okay, so among, or the between fn equals to n square and n plus 2, this function is having higher growth rate. Now come back to the definition of asymptotic analysis. So your asymptotic analysis is dealing with functions or polynomials behaviors at a higher or bigger value of input. This is asymptotic analysis. Now for implementation of this analysis, we have some tools called asymptotic notations. So we will discuss this concept in next tutorial. So in this tutorial you studied about algorithms, what the analysis of algorithm, how to analyze the algorithm, and why to analyze the algorithm. Okay, so for the we actually need asymptotic notations to compare or analyze basically the algorithms, which we will discuss in next tutorial. Thanks.